off. So I'm going to record it and put it on YouTube. So same as before, we will start with a little bit of algebra, and then we go to a statistic. Cool. So the algebra part, let's say we have a formula, which is m equal to a plus b over 2. All right. So this is actually the midpoint formula. If we have a number line, for example, this is 12, that point is 40. If you're looking for the midpoint, the middle of these 2 points, so that's the formula. This is going to be A, for example, and this is B. So if you plug it to that formula, you should get this point. Let's try. So I'm going to use the formula, which is 12 plus 40 divided by 2. This gives me 52. 52 divided by 2. 52 divided by 2, use a calculator, you should get 26. So this point will be 26. If we are in the x and y axis, let's say we have a line. We also can apply the same formula for the value of x and the value of y. Example, this point P is 2, 8, and point Q is 16, 20. So I'm not going to teach you guys algebra, I'm just saying we can use that formula, this formula, for x and y. So if you use that formula, we are able to find the coordinate of m. So we know we are in x and y axis, so this m should have x and y. What is m of x? I mean, the point m, the value of x, we will add, let me pick a color. And we have somebody in waiting room. So the m of x, this x will be adding the x's divided by 2. So I'm going to say 2 plus 16 divided by 2, which is 18 divided by 2 will be 9. So x value is 9. We do the same thing for m of y. M of y will be, the formula is this, the value of y divided by 2. So it will be 8 plus 20 divided by 2, which is 28 divided by 2 will be 14. So 9 and 14 will be the coordinate of this m. All right, so you need to know the algebra. The algebra part means you should be able to substitute the value and get the result. Let's have another formula. So the midpoint was basic, fully algebra, but now I'm going to give you guys z equal to x minus mu over sigma. So forget about the statistic part that mu is the mean, sigma is standard deviation, and x is the 1 point in our data set, and z will be z-score. So forget about that. I'm just giving you value for x, mu, and sigma, and I ask you guys what is z. So given x equal to 2, mu equal to 1.5, and sigma equal to 0.5, for example. So I give you this information and ask you guys what is z. So z should go to that box. Naz, we miss you on Monday. Brandon, Rocio, thanks for letting the camera on, but you're not there. Anybody solve this?
Yes.
Manuel, did you get it? Rocio,
Is it 1?
1. So somebody got 1, which is good, but we're not sure it's correct. Anybody else?
I got 1 also.
Very good. We got 2, 1, like 11.
I got 1 too.
111. Okay, we stop here.
Another 1.
All right, let me, that's great.
Either we're all right or we all did it wrong.
No, if you, all of you guys are wrong, it means something is wrong with the way I teach. So then I go on the question. All right, so again, there's nothing to do with a statistic. We just need to substitute the value and then find the answer. There's 2 gonna go here. 1.5 gonna go for the mu. 0.5 will go over here. So z, which has a line and minus here, you can change the color to dark brown. We have 2, 1.5, 0.5. So that's the first step. And you're not going to use a calculator to plug everything in the calculator. You can do this on the calculator. 2 minus 1.5, which is 0.5, divided by 0.5. Oh, you guys are great. 1. Okay, Apple. Okay, the answer was 1. Now, since you guys like the substituting, I'm going to change the x, y, z to some other value. So same question, same value of z. Now x equal to 2.323, mu equal to 1.297, and sigma equal to 0.241. So now tell me what is this beautiful z? What is the value of z? Since you guys are super good students, I give you guys multiple choice. A is 4.256. B, 4.257. C, 4.752. D, 4.777. So when you see multiple choice, you're
B.
just gonna randomly pick it, correct? So don't gamble here. Oh, let's go with A and B. So somebody said A.
No,
B.
Professor, I said B.
You said A.
B.
I got B2.
Too loud. Next one. Stephen, what's the answer? Just go. So you got B. Manpreet.
I got B as well.
Very good. Rasia.
B as well.
B as well.
All right, so we go with B. I believe you guys taught you guys very well. So B is correct. So, I mean, we don't freak out from all this notation, mu. We substitute it correctly, which is 2.323 minus 1.297 divided by 0.241. We use this in the calculator. We get the answer, whatever is that divided by this. All the answer will 3 decimals. So you need to go, you have to round it to 3 digits. It will be B, correct. Very nice. Let me give you guys another ugly formula that you will see it in this course later. Sigma of x bar equal to sigma over radical n. This is some type of error. I mean that sigma x bar is kind of error. Given sigma equal to 0.23 and n equal to 121. What is sigma of x bar? Anybody?
I try, Kayvon.
Is it 0.0019?
0.00.
19.
This correct.
I had a different answer.
What you get?
I got 0.020, 0.0209 or 0.021, I should say.
0.0.
021? No, just 10. Sorry, I apologize. Long day. I'm sorry, Kayvon.
Let's find
0.021.
You will say it one more time. I have
Okay. 0.021.
0.21. Okay, like that.
Yes.
Oh, I hope you're not wrong. I hope you're not right. So
Oh my God. Okay, well then let me change it back to point. Okay, let me do the math again.
So
I got
we are dealing with the calculator, correct?
I got 0.020.
Okay, that's good. I mean, this is kind of scaring me, but you got same as 0.020? Yeah.
Yes.
Okay.
Yeah, but if we're leaving, since you're saying there's 2 decimal points in sigma, then I would say it's just 0.02.
Okay. But here, so what we do, we just substitute first. We're gonna plug 0.23 divided by radical 121. So we see radical at the beginning, we just don't want to use a calculator. Radical 121, we can ask Musa, he knows that there's a perfect square, that's 11, correct, Musa? That's 11. So 0.23 divided by 11, what do we get? That's what we got. That's what you guys did, correct?
Correct.
That 0.02 something.
Yeah, 0.020.
Okay, I don't want to just go that much. So the point is, I don't want you guys to freak out if you see a formula like this, but Jared,
Yeah.
okay. good picture you used.
Oh, sorry.
So the point is you guys need to be good on substituting, and then when you substitute as a one part, then I know you have a fancy calculator or you want to use computer to calculate it, but the order that you guys use the calculator is very important. And let's talk about the interval notation that we talked on Monday. So we said on the number line, it says 0, positive infinity, negative infinity. If I ask you guys point A equal to 4, the equal sign, so you just go look for 4, it would be 1, 2, 3, 4. For example, point A is over there. But when we are dealing with inequality, that means you need to shade some part of the number line. Example, now I'm going to say B. The region B is X less than equal to 2, greater than equal to negative 3. So X going to be between two numbers. 2 is over here. Negative 3 will be right there. So we are dealing with this much of number, which is, I guess, infinite numbers. We have an equal sign right there. That means we are including 2. We also including negative 3. All the numbers between these two will be the solution. That's the inequality. We also can show it by interval notation. Interval notation, we use bracket because we have an equal sign with negative 3, comma 2. Question for you guys, graph X, which is parenthesis negative 1, comma 4 parenthesis, and point K or value K's are between negative 2, comma 0 parenthesis. So I want you to graph each one. So we are dealing with number line. This is negative infinity, positive infinity. That's 0. Negative 1 here, for example, 4 is there. When we having interval notation, so always interval notation comes with two numbers. I mean, the first one going to be the minimum value. So this is negative 1 is right here, and 4 is there. So we are dealing with everything inside. The parenthesis means we have open circle here, open circle there. This will be the solution. Good. And for K, we start from negative 2, we including it because there is a bracket. From negative 2, we go all the way to 0, but we don't include 0, so it would be open circle. And yeah, that's what inequality.
So you said if there's a bracket, it's a closed circle, correct?
Yes, we include it, yeah.
Thank you.
There's one more. Graph Y which is bracket 2 comma positive infinity. So in order to graph, so we have, again, we have interval notation. Minimum value is 2, the maximum value is infinity. So we have a number line, 0 here, for example, 2 is over there. We including 2, then we're gonna go this way. And you can just shade it, goes to positive infinity. So this means here. If you want to write it in inequality, this will be y greater than equal to 2. Is this true or false? Can I write an interval like 5 to negative 3?
No.
I mean, there's no way to go around the word to come back to negative 3. So always, so when we have interval notation, we need to have minimum value should be here and the maximum value should be there. So this is false. What about this one? 5 to positive infinity.
True.
For sure. Let's challenge people like Musa. Is that true or false?
The 5 to infinity?
Yeah.
True.
Manuel, what do you think? Manuel. Are you there, Manuel?
I'm sorry, I just got back. I'm at my job right now. I'm sorry, I wasn't paying attention right now.
That's okay. Thanks for letting me know.
Yeah, no worries.
Okay, I don't pick you. Let's go with the Steven.
Yes.
Are you working too, or
Yes, I'm writing down note.
reading my notes? Is that true or false?
Yeah, that is true.
That's true. Musa said true too. I would say it's false.
Wait, but wouldn't actually never mind.
I would say it's false, Mariana. You said true. Why is it is false? Why is false?
Because of the closed bracket.
Bracket.
For the infinity, correct? The closed bracket, not because the bracket here is little, not because of this, correct? Doesn't need to be perfect line. Because of infinity, because we have no idea what's happening in infinity, there is no number in infinity to just include that. So it has to be a parenthesis. So we cannot include infinity because we have no idea, is that like a ocean or what's happening there. So on interval notation, we cannot include negative and positive infinity. We always use parentheses. Any question for me?
Joined a little bit late, so like I still don't know what we're on to, but I've written some note down, so like I kind of understand now.
So we are same as before. We are doing some algebra first, and then we will go to a statistic that we almost done with the algebra. This is what we have done. Does that make sense?
Oh, okay. It's a lot.
So don't be late anymore. So we start with the midpoint. I mean, the midpoint of, that's a formula for the midpoint, a plus b divided by 2 if a is the initial and b is the endpoint. So the point, I mean, what we did, that was only applying substitution. Also, I'm going to post this video online, so you will see it. So I will put it on YouTube and email you guys the link. But if you guys subscribe me, then anytime I post something up, you should see it. I mean, you will get email that something is posted.
That's for Math 800.
Yes, that's, yeah. Right now we're going to Math 200. This is not 800 anymore.
Okay.
Any algebra question for me? All right, a statistic. So we should be done with chapter 2 soon. I'm going to wrap up everything that what we learned. And I picked few homework questions from your homework. We're going to work on that, and few other questions related to your homework, which would be good practice for us to do it. So the idea about the statistic is we have ugly table like this that doesn't make sense. The point is we would like to make it look pretty. This is not pretty, but this is data in eyes of AI, artificial intelligence. They might see data like this. We're not interested. We are interested in this one. This more welcoming, correct? Much better than all the pointing and much better than the table. The idea is we would like to make that data, all those numbers, to a picture like that. And the good thing is these days we don't need to calculate it by hand to find the maximum value or find the standard deviation and or mean and median. All of them computer will do it for us. So nothing by hand. All right, you can just use the calculator, or you can use the computer. I mean, there's a statistic page comes with the book that you can enter the data and visualize it. So your job is when we see a table like this, you should know what is this point, which is gonna be the maximum point. What is this point? That's what we are learning. We would like to know what is the minimum value of data, what's the maximum value of data, what is the middle point, the center, the median, the median and the mean, correct? That's what we are learning. Or the 5 different numbers, Q3, Q2, and Q1. Different type of visualization. We have histogram here, we have a pie graph. So we are learning different type of graph or visualization. At the same time, we would like to describe what that picture represents, correct? So do not freak out. Freak out if I give you this one. If I say, oh, what is this point? So this is scary. Freak out if I give you a table like this and I ask you guys, well, what is the standard deviation of this data? Then you have to use that ugly formula. So we're not doing this. If I give you guys data like this, you just you upload it to the machine and just click, give you guys a summary of a statistic. Your job is to say what is a mean, what is a standard deviation, all right? So that's what's happening. I know you guys have a fear. I know some of you guys, oh, this is super complicated. It would be great to don't have that fear and just enjoy the statistic and does all the visualization. Any question for me? So what's happening on this one, in this book, you will see a lot of ugly formula. Some of the ugly formula in Math 800, I'm going to ask you guys to substitute just without any meaning. You're going to just give me the value by simplifying. That's a different story. But in a statistic, I mean, so far you saw some ugly formula like z-score or standard deviation, for example. So what do? Let me see if I can do some. We use machine. This is the human, and that's the hand of computer that we're gonna apply to the machine. So we don't, again, we're not gonna use the formula, do it by hand. The machine will does it. Our job is to just talk about it. And this is us. All right. So we use the calculator. The machine is a calculator, and we are us. We just, and the good thing is you are taking the exam at home, so you just need to know the definition of each word. Cool. So I'm gonna review now. Let's get rid of this AI. We learn about the mean. Anytime you see a data, you should ask, so what is the average of this? What's the mean of that sample data? Your job is to know the difference between X bar and mu. We talked about the population and a small sample. We're not able to calculate the entire population, but we get the sample. We apply a statistic to get some information about population. So anytime you see mu, that means mu is for the population, X bar is for the sample. You already know about the sigma. Sigma means just adding. Then we learn about median. So median is going to be center of the data. Then we learn about the standard deviation that some of you guys pulled back. So, oh, what is this? Again, the standard deviation, it tells us how far the data are from the center. And then you go to z-score. So your job is to have the definition of z-score. Z-score should, I mean, should make sense to you. What that, if you get a value from z, what does it mean? So this S, standard deviation, X is a mean, X is a value in our data set. Whatever we get for z, it tells us how far, how many standard deviations that point is from the mean. Then we learn about 5-number summary. The minimum value, the maximum value, the median, quarter one, the first 25%, the last 25%. You guys can stop me if you guys have any question. I'm just gonna go through all the slide and then we're gonna do some exercise. Then we learn about outlier. So we talked about outlier that is up to, I mean, we usually like to apply statistic to a data with the outlier and with other outlier. Removing outlier, we need to decide is it a good idea to remove it or not a good idea to remove it. But definitely we should be able to determine if if there is an outlier in our data sets. So maximum, the maximum will be largest data value, and minimum is smaller. Quartile 1, median of the value below M, median of the values above M. Correct. If there is a data here, this is a median, this is a minimum, and that's the maximum. We would like to find the median of this part as well, which the middle point will be here. They call it Q1, the first 25%. We also like to find the median of the second half. This will be Q3. And our data set will be divided to 1, 2, 3, 4, which will be 25%, 25%, 25%, and 25%. Then we talk about the range. So range will be the maximum minus minimum. Interquartile range, IQR, is Q3 minus Q1. The IQR is resistance to outlier. The word resistance is kind of confusing. This means if you remove the outlier, nothing gonna happen to IQR. Because IQR, this is median, this is Q1, that's Q3. So outlier usually is there. If you remove it, nothing gonna happen to difference of Q3 minus Q1. So those were a definition that we're gonna use it entire this semester. We also talked about the shape of the data. When we graphing it, for example, is that shaped like this, which in this course, most of the time, the question is symmetry, like a bell shape. This is right skewed, and that's left skewed. That's the bell shape. Then we talked about percentile, why this is like, okay. So one of the layers is open. Okay. Percentile is a value which is greater than p% of the data. For example, if you are in 45 percentile, that means you are, I mean, if you got like a 45 percentile, if here is 0, that's 100, you are above 45% of all the data, or all the students. This will be 45 percentile. So that means you are above that. This. So now we have minimum, maximum, Q1, M, and Q3. So now we have a percentile. Here is 0 percentile. This is 25 percentile. That means if you are here, you're above 25% of everybody. So you are above 25%. If your point is there, you're above 50%. This is 75%, and that's 100%. If you got 100%, that means you're 100, your grade is 100% of, above 100% of all the other data. For the box plot, another type of visualization. So box plot, we start with the median. This line is a median, which is 50%, middle of the data. This will be minimum. This line is Q1. That line is Q3. And that's the maximum. So usually they call it lines or whiskers. So we learned that the data has middle. We have Q1, and let's say this is minimum. Then we have Q3, and we have maximum. So how do we make this one to a box plot? So we start with the median. We can just make a big line, correct? You connect this one to Q1 and connect this one to Q3. That has to be a box. And the line to median and line to a maximum. Sometimes making a data to a box plot is easier to visualize. So this is, I made it horizontally, but this example is, they made it vertically, which is fine. And so again, I mean, in this example, the maximum, for example, was, let's say, is 380. But you see some points there, correct? So the way they graphed it, they assume that those are the outlier. If somebody said, oh, I'm going to use this as a maximum, so this will continue to here. But there is a logic when you are using the box plot. The good thing is there is a formula that tells you if is that the outlier or not. The formula is this one. So Q1 minus 1.5 times IQR. If it's smaller than that, that will be the outlier. So let's say we have a data set like this. We already know to find the midpoint, median. We know how to find the Q1. And we have Q3. Now the minimum and maximum. So if Q1 multiply 1.5 times IQR, whatever number is less than that, it will be the outlier. So for example, we don't get those as an outlier, and I pick this as a minimum value. We do the same thing, Q3 plus 1.5 times IQR. We will see examples, so that's the formula. And you know how to calculate IQR, which is Q3 minus Q1. And this will be maximum, for example. Any question? So let's have one example related to this. We have a box plot here. So we have a data set, they graphed it. Now your job is to analyze this, to talk about it to your clients. Estimate the median. So they said estimate, we don't want exact. What is the median here for CEO?
60.
Very nice, yeah. So This is the median. This point is a median, so this is gonna go, let's say 60. Very nice. Estimate the IQR.
10.
What is that?
10.
10? Maybe, I don't know. But so IQR, the formula in your note sheet, they said Q3 minus Q1. This is Q3. This is Q1. This is Q3. Approximately. So I'm going to say 65 for Q3 and Q1. This is 50, 55. This is going to be I cannot read. 50 to 55, 5, well, 52. So minus 52. Correct? Again, if you don't know this formula, so definitely will be impossible to solve. I mean, you can even Google it. It doesn't make sense. I mean, you need to know something. 65 minus 52 is, so we line them up, 65, 52, 3, 13. So Kendall, you said 10, so probably you got 55, which is okay. It's an estimate. Estimate the range. What is the range? Musa, what is the range?
I have no idea.
Would it be close to, would it be like 30?
So the range, that's okay. So the range, the formula is
Maximum minus minimum.
minus minimum.
So it's like 30.
What is the maximum here? This is
65.
no. This
Like
this
7.
is 365. What is the
Yeah,
maximum?
it's like 70.
Musa, what's the maximum?
70.
71. Doesn't matter. 70, the estimate doesn't matter. Anything around. So we get the idea. This much is 5. This much is 5. It should be 68. But anyway, 70 is okay. Don't look at it as super complicated. Look at it as a fun. This is like a much easier than the math class you took it with me. So this is going to be 70. What is minimum?
52.
For 40,
Oh, yeah.
like 43, 42.
45. Oh, 46.
45.2.
Oh, God.
No, it would be 44.
You don't want me to write your exam like this, yeah? So follow. Okay, minus, so this is a minimum, 45. That gives you 25, right? So this is a range. All right. Let's have some other question for you guys. The exam scores shown in the histogram are, where's that coming from? Anyway, there is a data, I graphed the data in histogram, I got this. Good? So my question is this symmetric, left skewed, or right skewed?
Right.
Huh, Rocio?
Right.
Right. So I know the way you're looking at the data in the right, But actually, it's the other way. If the graph is like this, it will be right. If the graph is like that, it will be left. So whatever this tail, this is going to go. So it's left.
Oh.
Good. So I save you a point. So if it's exactly same, it will be the bell shape or the symmetric. But if this should be in your note sheet. Musa, what are you watching? Is it accident?
Outside my window.
My window, people having the table outside, so they are having dinner. I don't know how they're having dinner outside. This is scary. All the cars pass by. Also, there is not a good weather. Also, I don't know. But it looks like they're enjoying it. For sure, better than what we do. All right, so this is the left. So don't forget Rocio. It said right, but you got left. This is left. Not this one. The standard deviation for the hours of sleep per night is close to 1/2, 1, 2, 4. I have no idea. I have no idea. If you pick that, that means you're looking at the outside. If you don't look at the outside, you should have some idea. So no window. So let's say you're working on a big company, there was a data, somebody punched it in, they got a histogram. Now they're asking you what is the standard deviation for this? You're getting 10,000 per day. What is the standard deviation here? Kendall?
Pass.
E or just pass? You don't have
Pass. Pass, please.
That's great. I mean, I'm asking you a very super advanced question, but so the way you look at this one, correct? This is a graph that you know the histogram. Agree? You know that. Any word here you see, it makes sense to you. The only difficult part, I mean, there's sleep per night, but this is a keyword, the standard deviation. There's a definition in your notebook that say how far the data are from the mean. And there's a 95% rule. You should have this in your note sheet. 95%. We have some, I mean, only happens on the bell shape or normal distribution. So this is a median.
C?
What's that?
C?
Yeah. So we cannot just, I mean, you don't need to do some algebra to do that. No. Everything going to be, so this is going to be a bell shape. Good. What, in order to answer the standard deviation, we need to know what is the median, or what is the mode, what is the center of this. What is the mean here, approximately?
Between 6 and 8 hours?
The mean gonna be, I mean, not 6 to 8. I mean, here around 6 should be the mean, the center, the median, because we have, so this much are, so here to there will be 95%. Everything will be 100%, correct? They are saying use 95%. That means 95% gonna be from here to there. I mean, 8 is too far. 8 is over here. 4 is 6 will be the mean. So for 95% rule, that means we have 2 standard deviation here and 2 standard deviation over there. So this much should be 2 sigma and that one should be 2 sigma. So this is should be 2. That's 2 gives you 10. Again, exactly same. So 2 will be the answer. Okay, in this slide, 95% rule. This is a mean. When you find the mean, that's we calculated to be 6, correct? Then we had a bar here, we had another bar here, we had another bar here. This much is X bar plus a standard deviation. We had 6, we picked 2. You could use 1. One of them was half, another one was 4. If you add 4 to 6, you're going to get 10. You're going to go, after 2 standard division, you're going to pass all the data. Proceed. Good. Yeah. So, and also 2 standard division this side. That's a 95% rule. Now, if you look at this one by that information with the slide that I show you guys, when you find the mean, we should have 2 standard deviation to get to 95%, and 2 standard deviation this side, which the 2 will be the best one. If you pick 4, mean 1, 10, another one going to be 14, going to be here. It's not right. If you pick 1/2, it will be here. That's not going to be 95%. Another 95% rule. Based on student survey data. Rates for this. The good thing is always we are dealing with bell shape. Later you're going to call it normal distribution. So what do we have? We have mean of 69.6. Good. Should I put X bar or mu? Is that X bar equal to 69.6 or mu equal to 69.6?
X bar.
X bar, correct? X bar is a sample. We are sampling. We don't do all the population. So this is a population. So this is not correct. So X bar. So we are dealing with X bar. And the standard deviation is 12.2. Good. And we have S equal to 12.2. What interval is likely to contain 95% of the pulse rate in this sample? What is the interval? We read it a few times to make sense to us. Then we start drawing something. Draw happily, make a line. We know they said bell shape. So we know we have to be something like this, like mountain. As a sun of the prime. So the mean is 69.6. And the standard deviation is 12.2. Now I'm going to ask Mariana, how, this is what interval, I mean, how far does it go? I mean, 69.6 is a mean. What do we know about 95%? A maximum, it goes 2, correct? We're gonna go 1 standard deviation here. What is the standard deviation?
So that's
0.2.
12.2, yeah,
If you add it, what do we get?
81.8.
Very nice. You have to have another one, 12.2. What do we,
94.
exactly? Okay. Good.
Yes.
So
And then
now we're taking over
106.2.
there. Very good. 12.2. So now we're subtracting. What do we get?
$57.4.
Okay, another one.
45.2.
So what interval from 45.2 to 94, that 95% of the data, I mean the number is between 45 to 94.
The 94, right?
94, yeah.
That's
So what did I say? 94. Yeah, from 45.2, you said 94. 81.8 plus 12.2 is 94, yeah. That's the interval. I mean, this bell shape gonna be like this, almost. Correct? This is a mean. This much is 95% of the data. So 95%, the number is from 45.2 to 94. Does that make sense?
yes.
Yeah. Musa, it's much better to look at the outside. You just look some depressing.
No, I'm writing down notes.
Okay. I post this on YouTube, so you can just keep watching YouTube. Put your Apple TV. Keep seeing. So let's do this one. Which is better, an ACT score of 28 or a combined SAT score of 2,100? You can do it, Musa. You guys can do this. I mean, you got 28% in this ACT. Is that a good, not 28%, 28 on the score? Is it 28 better or 2,100? I know 2,100 is a huge number, but they're different scale. Which one is better score? On Monday, we talked about the, I said, a final exam when you got different, when you get a grade, I usually look at the mean and say how far you are from the mean. So that's what we have to do. We have to say the average, for example, for the ACT is 21. Is at 28. How much is far away from the mean? And so that's how it gives us some percentage. So in order to do this, we use Z score. So Z score, Z, we said it tells us how many standard deviation you're far away from the mean, right? That's the definition of Z score, which is X minus mu divided by sigma. Let's do this. Let's find the Z score from ACT, and let's find the Z score from SAT. Can you guys tell me what is Z score here and what is Z score there? Substituting, that's what we start the class today. If we substitute, Musa, what do you get for first one?
I don't know. I didn't answer it yet.
So it's C. You answer C. So we substitute. Anybody solve for the first one?
Is it 1.4?
Yeah. So we have, so the mu we have, so x is 28, correct? You got 28, or 28 minus 21 divided by 5 gives me 1.4, as Mariana said. And for this SAT, we have 2,100 minus 1,500 divided by 325. What is this one?
1.8.
So we have 2Z score. Now, which one is a better score?
B.
Which one?
B.
B is 1.8.
Oh.
No, that's fine. You're right. It's 1.8 the standard deviation from the mean. So that means it goes through the hundreds, right? Okay. If this is like a mean is 1,500, correct? So you got one, and the standard deviation is 325. So this is going to be 1,825, right? The next one going to be 2,150, something like this. 2,150 if you add 325, 5. Yeah. So that means you're around here. So you're almost close to 2 standard deviation. 2 standard deviation going to be the perfect. I mean, you're going to get almost perfect. So 1.8, because here you're going to start for 0, correct? If you're far away from the mean, that means you're closer to get 100%. This is 1.4 standard deviation from the mean. So this is like a 91%, and this is 97. Both of them are good, but this is 97%. This is a better grade because you're far away. So, correct, Mariana? You were looking at it differently.
Yeah, I was.
So, if you get a better Z in this particular question, because Z is higher, for the grade is much better. You're closer to getting perfect score. So B is correct. We have a data set. So we have a data set. We don't have a graph, but somebody give us a 5-number summary. Minimum, that makes sense to you, correct? That makes sense to you. Maximum, you love it. Median, you know it. First quarter, you know it. Third quarter or Q3, you know it. All of them make sense, correct? But we challenge you. With that data, how can if you picture the graph, you think it's symmetric, right is skew, left is skew, or impossible to tell, or we don't have enough information? What do we know about distribution of number of hours spent studying each week?
Left skewed.
Left is skewed?
Yes.
Yeah. So for the 5 number, it will be symmetric if the distance to be same. All of them should be same distance. It will be symmetric, right? But now what do we have? What's the distance from median to first is 5, which is good. Also median to Q3 is 5. But we cannot just make a conclusion here. Then first to the minimum is 7. And Q3 to maximum is 49. Good. What does it mean? That means here is 69, then here is 20, and 15, we have 10. So the left is Q or right is Q?
Wow.
Kenneth, why this is left?
Yeah, left.
This is right is Q because the 69 is part the max. This is the point on the data. So I need to get this. So this is a median. 15 is a median, correct? So median is here. I need to get to that 69. So it will go to the right. It would be right skewed.
I'm so confused.
You're not alone.
But it seems like it's gradually going up, so it would be like a maybe. Am I tripping?
No, that was my thought too. Like the
Yeah, so I'm
69
thinking it
have
would be like a
higher
No,
bar.
how do we know that this is gonna go up, or how do we know it's here?
because
The 69 is greater.
No. 69 is, we have a data, one of the point on the data set is 69. The minimum is 2. If you have 25% of data here, 25% here, 25% here, 25% there, so the data gonna go like this.
Okay, that makes sense. I mean,
Does
looking at it visually now, because I get what the other classmates are saying. I guess it's just the way that we visually look at it when it's like on a more of like a y x axis, right? Does that make sense? Like,
Okay. Let's say we have a data set, this is a student's name, A, B, C, D. We have like most of them are 15. In the center of data is 15. Most of the students study 15 hours a week. But only one of them, for example, C, studies 69 hours a week. But that doesn't mean a lot of people study 69 hours a week. On the 69, only probably one person studies 69. So this is gonna go tell our graph gonna get this as well. We have more example like this, we will see.
hey, stop.
So this mean or median, then
So then wouldn't it be symmetrical because it's going to go from 10, 15 to 20, the shape? Because you're leaving out the 2 and the 69 if you're using the 95%. Maybe I'm making a bigger mess.
No. That's great. That's great. So let's say we have 100 students, correct? 100 students, I have to put 25 of them here, 25 of them there, 25 of them there, 25 of them here. So here we have so much points. All the points going to be small because it's long from 20 to 69. If you have to put 25 people here, correct? Right. I have to put 25 people on the 7 and 8 interval. So I can put you can actually put 25 people. You see 25 people going to go here and 25 people going to go there. But when you put 25 people here, it will be like a 169, we have 150, 1, all of them going to be small. We're not going to have 25 of them to be on 69, right?
Got
No,
it.
you have to wait for Caleb.
So it will be,
Why don't you play games on your tablet?
I don't like this example. I don't like this example, not one bit.
I have, let's do here.
Ask Papa. I think he
We
knows.
haven't studied 69 hours.
Let's work on this one.
So I'm sorry, real quick question, because I'm trying to take notes of that. So is that one going to be what was the answer to that last one? Is it right?
The right.
Skew?
Let's go to right.
Hmm.
Let's work on part B on this one. So same question. We have 5-number summary. What do you think this will be? Is that symmetric, left, or right? So 5-number summary, that means
That's gonna be symmetric.
this is minimum, that's maximum, this is median, this is Q1 and Q3.
That's symmetric
Why?
because the difference is the same between each interval.
Yeah, I agree.
But that last one though.
Okay, so this is your idea of symmetric. Right? That means this median, there are 25% here, 25% here, 25, 25. So it will be symmetric. It's correct. This is symmetric. What about first one?
Would that be right? I'm sorry, left skewed?
Yes, would be left. But you just picked it left or?
I don't know. The numbers are higher towards the end, so it just seems like it would.
So let's see. We have 10. So minimum is 10. Q1 is 57. Median is 85. $88. And maximum is 93. So the way I did it, that's not 10 here. Correct? Kendall,
Yes, sir.
don't give up. Give me the, so this is a minimum. So the range of data is okay from 10 to 93. To subtract, you get 80. That's 83. That's a range. So from now, what do you think the answer is going to be? Is that going to be like this? Or is it going to be like that? For sure, you're not going to say symmetric because you got the idea has to be same interval. Good?
Correct.
Now, tell me which one. Is that A or B?
It's gonna be A.
I still think it's A.
Is A correct? It goes to the left. Who said is A? It means A, correct?
Nice.
Yeah.
Said it.
But Kenneth, do you see it's right or is it A or B? So in order, this is
Yeah, I said A. Yeah,
Yeah, that's
said,
A.
That one's still easier than the very first one.
Was it-
I'm
No,
still I wrote it down. I wrote that one down, and I'm still looking at like how is that right skew?
no. So you know that this is left and that's right. The way the shape.
Yes, correct. Yes, exactly.
Again, we have like 100 dots. We're going to put 25 of them here, 25 of them here, 25 of them here, 25 of them here.
So it's more spread out.
Yeah.
Yes, correct.
So now let's work on part D, and then we go to your favorite question. What is D?
see, I'm gonna say right skewed because of the very first question, but I'm gonna say it would look like it was left. But maybe like she said,
5,
I'm thinking of the XY
7,
interval.
8, 15, and 42. And 42 here. So here, if I want to put data, I mean, again, I'm going to put 25 data here. Definitely 25 going to stack up, correct? Then 25 here. This is only 1 unit, that's 2 units, so it's going to be more. Then we have less over here and less over there. So it will be like this, which is goes to the right. All right, Rocio?
I guess so. I'm still trying to figure
But
this
you
out
said
myself.
you answered it.
Yeah, I don't know. Practice.
What about C?
Can you do this one more time?
Part D?
D,
Sure.
yeah. Just because you said more, and then when you start moving towards the end, you said less. That's what I didn't understand.
So we have D. So there is a data here. We have, this is a minimum. I'm going to start with 5.
Yeah.
Then we go to 7. So 7, here is 6. Then we go to 8. Then we go to 15. Then we go to 42. So we have 15 as Q3. 8 is a median. So the 8 means it's half the data. So half of the data going to be here and half of the data going to be there. That's another way to see it. So do you think the 50 dots can stack up like this, or is going to be a spreading out between 8 to 42?
Spreading out?
So it's going to be like this. 50 of them going to be there. And other 50, so for sure other 50 going to be there, should be less than between the median and the minimum. So the data, well, if you graph it, it will be something like this. It goes to the right.
Okay. Need a different color so I can see that.
Mariana? You're mute.
Now it makes sense.
Good. So the
Now that you explained it like that, like I had to see it.
Median, we'll talk about, I mean, we divide, median means middle of the data.
Yeah, I mean, I knew that's what it meant, but visually, my brain wasn't. So yeah, now it makes sense.
Should we do one more, or are we gonna mess it up? Let's do one more. So now look at the practice, I'll make it easy. Now we can say it. We have 5, then we got 25 to 30, then 40, then 50, then 75. So we have 25 units here. We have 25 units there. We have 10 and 10. Kenneth, what is that? Oh, Kendall, sorry.
Oh yes. That's right. That's skewed. Yeah, that's right.
You're answering and you correct me?
Oh, hold on. Time out. Wait. Nope.
No, correct.
That's
exactly same distance. Exactly
yes,
same. So
yeah,
it has
that's
to be
sim.
bell shape or symmetry. Good. This left or right? Describe the shape of the distribution. Is that symmetric, skew to the right, or skew to the left, or none of them?
That one's skewed to the left.
Sure, yeah.
Left.
This is goes to the left. Very nice. That's true. It goes to the left. This is true. So it doesn't need to go exactly sheep goes all the way. You don't see my hands all the way. But as long as it does is not to right and it's not symmetry, so we only left with the left. Which of the following value is closest to the median of the distribution? The median. This is a homework question. Correct? You guys done this?
5.
Who was that?
Musa.
Musa. Oh, you turned the light on.
Yeah, I have one now.
So is that 5 correct? They said median. Median should be middle, correct? Middle of the data. 50% here, 50% there. And they said estimated. So 3.5 is over here. That's not going to be true that 50% of data to be there and 50% there.
Okay.
5, okay, that's Musa said that, let's say, just don't break his heart. Okay, 5 maybe. What I mean, 5 is here. Is that possible to have 50% here, 50% there? 8, definitely not. 7.5, not. So between 5.5 and 6.5, which one do you pick? Which one is the best one?
6.5.
We go with 6.5, yeah. This is 6.5 somewhere on here. 50% here, 50% there. It's too dark, Musa, you don't see it, but 56.
Yeah, that's what it is.
So median is in middle, and then, so they're not saying exactly, so they give us all the option between 5.5, this is going to be 6, 5.5 going to be there. Again, is negotiable, so much data there. We cannot say 50% here, 50%. So 6.5 is the best candidate. Will the mean be a smaller or larger than the value you give for the median? So median we said is 6.5. That's the last question. This is the median. Is that mean gonna be over here or is gonna be over there? Is it gonna be more than 6.5 or less than 6.5? Catherine?
Less than 6.5.
Less than?
Yes.
That's true. It's smaller. We had one example like this in like a week ago. We said if it's this, not this type of graph is kind of hard to say, but when they said skew to the left, when we have a skew to the left, so you can visualize something like this, correct? Now, when it goes to the left, if that's the median, mean gonna be less than that. If it's skewed to the right, the mean gonna be more than median. So that's how you're gonna just write it down. But why is that? Because it goes to the left, correct? So there are a very small point there that it kills the median. It kills the mean, make the mean smaller.
So is that, so anytime it's left skewed, it's gonna be less than?
Yes, anytime if it goes to the left, the mean is less than median. If it goes to the right, mean is more than median.
Mm-hmm.